Project is called Task Hub. It's a it's a client server to-do manager application built using Java, Spring Boot, Java Swing, REST APIs, Gradle, and the D4 methodology. The goal of this project was to build a desktop productivity application where the users can manage tasks through a graphical interface while the front-end client communicates with the back-end server using REST APIs and JSON data. The application allows users to add tasks, complete tasks, delete tasks, refresh tasks, and reorder tasks, and using move up and move down buttons. I wanted the project to feel more like a real productivity application instead of just a very small classroom example. I also wanted to better understand how front end and back end systems communicate with each other in a client server architecture. So, this is my Task Hub folder. Inside it, I have the backend server and the front end client, the design document, the Gradle configuration files, source code, build folders, and runnable jar files. Before starting development, I first brainstormed two possible project ideas. I brainstormed two possible project ideas. The first idea was EduPlan, which was a study planner application for students where users could basically uh, manage assignments, courses, and study sessions and deadlines. The second idea was a task manager, and which focused more on productivity and organization. After comparing both ideas, I decided to continue with the task manager because it was simpler, more realistic to complete within the project timeline, and still allowed me to implement all the required technologies like Spring Boot, Java Swing, REST APIs, Gradle, and client server communication. After choosing the idea, I followed the D4 methodology. I discussed features and project structure with Gemini. I talked about the REST API communication, uh, GUI layout, error handling, project organization, validation, and possible edge cases. After brainstorming process, I asked Gemini to generate a design document that would act as a blueprint for the coding phase. So this is my design document, and this is the design document. It includes uh, the project overview, data model, REST API specification, server-side design, client-side design, threading model, testing plans, Gradle configuration, and implementation notes. One thing I learned during this process is that the design document is very important in D4 because it gives the coding agent a structured plan before generating the code. Instead of randomly asking AI to build an application, I first described exactly how the system should work. So the project separated into two major parts, the backend server and the front-end client. The backend client is inside the Task Hub server folder, and the front end is inside the Task Hub client folder. The backend server is responsible for storing tasks, validation, REST API communication, and business logic. The front end client is responsible for the graphical interface, displaying tasks, and handling user interaction, and sending HTTP requests to the backend server. So first I'll open the task controller the task controller.java. Yeah. So this file contains the backend REST API and backend REST API endpoints. The code uses Spring Boot annotations to handle HTTP requests. The get mapping method retrieves tasks from the server. Uh, The post mapping method creates new tasks, and the put mapping method marks tasks completed, and the delete mapping deletes tasks. These methods prove the REST API communication requirement because the front end and back end communicate through HTTP requests and JSON data. One interesting software design example in the generated code is the separation between the front end and the back end. The front end Java Spring application and the back end Spring Boot application are completely separate programs. The front end only handles the graphical interface and sending requests, while the back end handles task storage, validation, business logic, and the REST API communication. This separation makes the project easier to organize and maintain. For example, theoretically, I could replace Java Swing front end later with a web front end or mobile application while keeping the same backend REST API. Now I'll open task service Java. So another interesting design example is the layered backend structure. The controller handles API requests while the service file handles business logic and validation. This keeps the code cleaner because everything is not mixed together inside one giant file. Now, task hub GUI.java. This file contains the front end. It contains the front end GUI code. It controls the window, buttons, table colors, fonts, and user interactions. Another interesting thing in the generated code is that the GUI performs HTTP requests in background threads, so the interface does not freeze while communicating with the backend server. I also want to reflect more on the generated code. When I looked at the generated code, I noticed that Gemini separated the project into clear parts instead of putting everything into one file. For example, uh, task controller.java handles the REST API endpoints, task service.java handles task logic and validation, and task hub GUI.java handles the visual part of the application. I think this is a good software design choice because each file has a clear responsibility. Code is easier to read and understand because the GUI code, server logic, and task logic are separated. Now I want to talk about the and reflect on the development process and discuss examples where AI gave me the wrong thing. The first issue happened with the graphical interface and design. Uh, it basically happened with the graphical interface design. Originally, Gemini generated a very plain and outdated looking GUI. The application technically worked, but it looked too basic and unpolished for a final project. The spacing looked crowded, the buttons looked plain, and the overall layout looked like a default Java Swing demo. To fix this, I went back to Gemini CLI and specifically asked it to redesign the interface and with modern fonts, colorful buttons, improved spacing, cleaner layout, and better table styling. I also specifically requested move up and move down functionality because I wanted tasks to be reorderable like modern productivity applications. The second issue happened during testing. At one point, I launched the front end client before starting the backend server, which caused connection errors. At first, I thought the client application itself was broken. After debugging the issue, I realized the front end depended on the backend REST API being active first. I fixed this by launching the backend server before starting the front end client. Another challenge during development was understanding the generated code itself. AI generated many files automatically, so I had to spend time reading through the project structure and understanding what different files were responsible for. Reading through the generated code helped me understand how Java client server applications were organized. One weakness or limitation of the generated code is that the tasks are only stored in memory. This means if the backend server closes or restarts, all tasks disappear permanently. If I had more time, I would add a real database so tasks stay saved permanently even after restarting the server. Other future improvements could include user accounts, due dates, synchronization, drag and drop, ordering, and mobile support. Now I'll jump to the application. This is basically the client and server working. So finally, this is the client and server working in the PowerShell. Now this is the main application, which you can see Task Hub. You can basically add whatever you can. Wait a minute. Let's delete this. You can basically add any task. Like let's go for a walk description tomorrow, and then you can add the task, and you can say let's have tea. You can add this task, then you can add more, you can add as many tasks as you like, and you can add description, and then all of them will be arranged in the table below. And then you have the ability to click on the task, and then you can move it up and rearrange the order, and you can also refresh it to go back to the original order. And you can click on the task and then mark it completed, and you can also click on it and then delete the tasks. So this is basically uh, overall you can create as many tasks as possible, and you can delete them and move them up and down. Wait a minute. You can basically move this up, then move it down. You can click any task and you can rearrange the order it and basically, yeah, and then you can click on it, completed, completed, completed. Similarly, you can refresh tasks and delete them, and that's basically the purpose of this app. It's basically a to-do list app where you can add your whatever tasks you want to perform. You can arrange them in a list and rearrange them in whatever order you want. And this basically the my this was basically my task hub application, and I feel like this project has and yeah, I also have the runnable jar files. This is like one of them, and then you can go back and see the second one. This is the client uh, jar file, and then I'll show you the server jar file. This is the server jar file. The previous one was the client jar file. So overall, this project has taught me a lot, and it helped me understand REST APIs, Spring Boot backend development, Java Swing GUI development, Gradle builds, client server architecture, interoperability testing, and the D4 workflow using AI coding agents. It also taught me that AI generated code is useful for rapidly building project structure and features, but debugging, testing, and improving usability and understanding the generated code are still important responsibilities for the developer. Thank you.